Hello everyone, today I am going to make the family of a folding door in Revit. So let's start. Open new family template file of door. This family already has some built-in references which are required for the modeling of a door, so it saves a lot of our time. First of all, I am going to reduce the size of text. This template has an opening of 3 feet and I am going to make it 6 feet in total, 3 feet on each side. First of all, I am going to assign a parameter of frame plus wall thickness here. Click on it, click on parameter properties and give the name to this dimension. This is a 6 inches wall, but I need a 9 inches wall, so I'm going to change the thickness of wall. Now go to 3D, reduce the size of text. In the create panel, click on extrusion, set the reference plane to this frame, go to interior mode and draw a frame for the inside area. Make an offset of 1 inches on these 3 sides, fillet the edges. Close the frame and give the extrusion end to frame plus wall thickness, so that whenever you change the thickness of wall, this frame also changes its position. Go to plane, mirror this frame as it has extruded in the opposite direction. Now you can check that whenever you change the thickness of wall, the frame also moves along with it. Join this frame with the outer frames. Now select these frames one by one and change its material to whatever you want. Now I am going to add some reference planes here and here. Add these 2 reference places in the right side as well. Now add dimensions between these 2 reference planes and these 2 reference planes as well. Repeat this on the right side as well. Assign parameter to these dimensions. This is the opening width including frame. Now assign parameter to this dimension and name it opening width without frame. Now go to the properties panel and add a formula that opening without frame is opening width including frame minus 1 inches. So whenever you change the dimension of this area to, like for example, 4 feet, this dimension will automatically change because of that formula. Now add a reference line at this point and at this point as well. Assign parameter to this reference line and name it panel width. This is going to be the width of one panel. Now go to the properties panel and add a formula in panel width. If I am going to make a 6-panel door with 3 panels on left side and 3 on right side, then I am going to divide it by 3. But I am making a 4-panel door with 2 on left side and 2 on right side, so I am dividing it by 2. This subtraction is very important because if the reference line of left side are joined together with the reference line of right side, it will create an error. So I am creating a very small distance among them. Assign the parameter of panel width to this reference line as well. This step is very important, so look carefully. Click on align, click on this reference plane, move the mouse here, press tab button on keyboard, again press tab button on keyboard, see a blue dot here, click on it. This open lock appears here, click on it to close it down. Now click on this reference plane here, move mouse here, press tab button on keyboard. This blue dot appears here, click on it. Now an open lock appears here, click on it to close it down. Now this reference line will move between these two reference planes only at this point of junction. Now repeat the same process here as well. Now select the angular dimension and place this dimension between this reference line and the reference plane. Assign parameter to these angles and name it left angle and right angle simultaneously. Now add some different angles here to check that the reference line rotate correctly. You can see that by changing the width here, the panel width also changes its dimensions. Go to elevation and assign a dimension here. Assign a parameter to this dimension and name it panel height, which is actually the height without frame. So I am going to add a formula to the panel height that it is the height minus 1 inches. 1 inches being the width of panel. Go to create, select extrusion, set the reference plane to this reference line and make a rectangle with a thickness of 1/3/4 of an inch. Constrain the extrusion end to panel height so that whenever the panel height changes, this extrusion also changes its dimension. Repeat this process on this reference line as well. Now place 3 vertical reference planes here on the left side and here on the right side. Assign dimensions between these three reference planes as shown. Now this is a right angle triangle with the diagonal side being the hypotenuse, the bottom side being adjacent, and the right side being the opposite. Now I want to know the adjacent side, so the formula for that is hypotenuse into cos theta. The hypotenuse is the panel width and cos theta is the angle, left angle. So assign parameter to this dimension and name it left adjacent. Assign parameter to these two dimensions as well and name it left opposite. Repeat this process on the right side as well and name the parameters as right adjacent and right opposite. Go to Properties panel and add a formula in the left adjacent and the right adjacent. The formula is panel width into cos left angle. The formula for the right adjacent is panel width into cos right angle. There is a small right angle triangle here as well. The diagonal side is the hypotenuse, the above side is the the opposite, and the right side is the adjacent. So I'm going to add the formula of opposite, which is hypotenuse into sine theta. The hypotenuse is the panel thickness, so assign a parameter and name it panel thickness. Go to Properties panel and assign the formula in the left opposite, which is panel thickness into sine left angle, as the angle of this right angle triangle and the previous one is the same. Assign a formula of panel thickness into sine right angle in the right opposite as well. Now by changing the angle, the reference planes move as well. Place two horizontal reference planes here and here. Place a reference line on this point till this reference plane and this point on till this reference plane. Assign angular dimension between this reference line and reference plane in the right and left side. Select a line and lock this reference line on this point. And this point. Repeat this process on this reference line of right side as well. Assign this angular dimension the parameter of left angle and this angular dimension the parameter of right angle. Assign these two newly drawn reference lines the parameter of panel width. Make a panel on this reference line with the help of extrusion. Now you can see that by changing the angle, the panel moves in the required angular dimension. By changing a single dimension, all of the dimensions are automatically changed because they are all linked together by the formulas. So it is very important to add these formulas. Go to the elevation and subtract a chunk between these four panels to place glass with the help of void extrusion. Now assign a dimension here and name the parameter as glass height. Go to Properties panel and add a formula in glass height, which is height minus 7 inches. Go to Plan and draw the glass with the help of extrusion as shown on all of these 4 panels. By changing the height here, the glass automatically changes its height. Assign material to these glass panels as shown. Assign the materials to the panels as well. By changing the dimension, the glass panels move upwards. It is because it is not locked down. So select the panel of glass and lock it down here and lock it in the bottom side as well. The family of folding door is now complete. Now open the project on which you want to place this folding door. Import this family and place it on the wall. I'm going to place it here. This is how it looks like in the 3D. By changing the dimension, this glass panel does not move along with the wooden panel. Also, this glass panel is slightly longer than required. Double click on this family of door and lock all the glass panels on this point and this point. This glass panel on the right side again moves, so I am again going into the family of door. I am going to delete this glass panel and again draw it with the help of extrusion. You can also flip the direction of this folding door by clicking here. Place a camera here. Adjust its view. And render it. This is how it looks like in the rough render. So this is all for today. I hope you like this tutorial. If you have any queries, feel free to ask. Also, if you want me to upload any specific tutorial, just tell me and I will try to upload it as soon as possible. I will meet you guys in the next video. Till then, goodbye and take care. And most importantly, don't forget to like, share and subscribe.